Hi, welcome to section 2 for notes. This is on deductive reasoning. We've already talked some about inductive reasoning earlier in the chapter, and inductive reasoning, just to review over that, is the type of reasoning that reaches conclusions based on a pattern of specific examples or past events. So like in section 2.1, when you were looking at those different patterns of numbers or letters or words, you could look at that pattern and then use that pattern to help you determine what the next couple of terms were. And you were using inductive reasoning to do that. Deductive reasoning is what we're talking about today. And deductive reasoning uses facts, rules, and definitions, or properties to reach logical conclusions. It's the process of reasoning logically from given statements or facts to a conclusion. So it's kind of a process. So I'm going to show you this 6-minute video next that I think describes really well the difference between inductive and deductive reasoning. It will kind of give you an overview of what they are, and then it will give you some specific examples of each. So I would like you to take some notes while this video is playing on your notes page under inductive or deductive. You don't have to write down everything that is said, but I want you to end up with a little bit of a general overview of what inductive reasoning is and maybe at least one example of it. And same thing for deductive. So as you're watching the video, kind of jot a few things down, and that'll help you kind of keep straight what the difference is between them.
Hi, and welcome to this video on inductive and deductive. There are two basic styles of reasoning used to construct an argument. Assuming that the premise is true,
All right, so back to our notes. So hopefully you jotted a few things down. Hopefully that kind of helped you see a little bit of the differences between inductive and deductive reasoning. And now the rest of the notes today is we're going to actually be using deductive reasoning. She actually mentioned the type of reasoning that we're going to be using today, and that is law of detachment and law of syllogism. So we're going to see some more specific examples. Like she was saying, it's basically kind of like a formula that we're using, and if the statements are set up in that formula, then we know that we can reach a true conclusion with that formula. If the statements we're given are not set up in that formula, then we are not going to be able to reach a true conclusion from that information. So the first one we're going over is called law of detachment, and it says a form of deductive reasoning that is used to draw conclusions from true conditional statements if the hypothesis of a true conditional is true, then the conclusion is true. So you can see this statement we have here. You know, if P then Q, that's our if then statement, is true, and if P is true, so we've got if P then Q, P is our hypothesis, Q is our conclusion. If that's true, and if they state something else where they're basically restating the hypothesis but with a specific example, then the conclusion that we can come up with is that Q must also be true as well. The way I usually like to write this, they have it kind of written horizontally. I like to usually write this vertically, where I say, okay, if P then Q is kind of what the first statement is going to be. It's going to be an if then statement. And then it's going to be restating P with a specific example. And then I know that my conclusion then, if the first two lines are set up like I have here, then the conclusion must be that Q is true. Okay, but it has to be set up in that original formula first. So if you look at example 2, it says, given the following statement, determine the conclusion. So what's given is that if a car is a RAV4, then it's a Toyota. That is my if-then statement. That's my P and that's my Q. And then the second statement says, Mr. England drives a RAV4. So they're still talking about P, that first statement, but they have a specific example of Mr. England driving the RAV4 and just instead of just in general talking about the RAV4. So since it is set up like this exactly, then I know that I can just restate Q with that specific example, and I know that's going to be a true conclusion. So the conclusion that I can make is just restating Q with the specific example of Mr. England. So I can say that Mr. England drives a Toyota. Okay. So again, that's just a process of seeing if it is set up like law of detachment, and if so, I can reach a true conclusion with that. All right, on example 3, it says use the law of detachment to make a conclusion. If not possible, explain why not. So in this case, they just have it written horizontally, but still same idea. If a triangle is a right triangle, P, then the triangle has one 90-degree angle, Q. It says triangle ABC is a right triangle. So it's basically restating P with the specific example of triangle ABC. And so therefore my true conclusion is Q. I can basically restate Q with the specific example of triangle ABC. Instead of just saying the triangle has one 90-degree angle, I'm going to say triangle ABC. I'm going to be more specific, has one 90-degree angle. And I'm going to show you off to the side here again what the law of detachment is. And I just think at first it helps to see it. This, I would, if I was taking a quiz or a test with this stuff, I would remember that as a little formula to write at the top of my paper and then use that to help me answer the questions about law of detachment. Okay, on B, let's switch colors here. On B, it says if a parallelogram has 4 congruent sides, then the parallelogram is a rhombus. So here's our P, here's our Q. And now our next line is basically restating P with the specific example of parallelogram ABCD. It says parallelogram ABCD has 4 congruent sides. And so now my conclusion is Q. So I want to restate this with the specific example of parallelogram ABCD. So I'm going to say parallelogram ABCD is a rhombus. I know that's a true conclusion based on the way the other statements are set up. Okay, on the next one, it says, if cats prowl, mice will scatter. So here's my P, here's my Q. It doesn't technically have the word then. Sometimes you don't see the words if and then, but you can still assume the first part's the hypothesis, the second part is the conclusion. Now, this says mice are scattering. I want you to think about, is that restating P or is that restating Q? And in this case, it's actually restating Q. It's talking about the scattering, the mice scattering. So because it is not set up over here, because it is not set up like my formula, I cannot reach a valid conclusion with that information. So I'm just going to write no conclusion. And it should make sense that I'm not going to make a conclusion, because just because mice are scattering, does that mean that cats must be prowling around? Try and think of what are other reasons that mice could scatter. It could be a loud noise, someone dropped something on the ground, people walked in the room, someone dropped some food and they started scurrying over to go get it. A dog came in the room. So there could be a lot of reasons that mice scatter. So just because mice are scattering does not automatically mean that cats are prowling. So again, it should make sense once you think about it. All right, next one is if a triangle has two congruent sides, so that's my P, then the triangle is isosceles, that's my Q. And if you think about what isosceles means, that's probably something you've gone over in past years. Isosceles triangle is a triangle that has two congruent sides. Okay, so now we've got in triangle DEF, we're talking about a specific triangle. DE is congruent to EF. That helps you to draw a picture of what's going on. You can certainly do that. So it's saying DE is congruent to EF. So basically that is restating P with a specific example of triangle DEF. So therefore my valid conclusion is going to be restating Q with this specific example. So I'm going to say in triangle DEF, the triangle is isosceles. It probably would have been better just to say triangle DEF is isosceles. Probably didn't need that many words, but that's okay. All right, so moving right along, we have one other law of logic using deductive reasoning, and that is the law of syllogism. So the law of syllogism says it allows you to state a conclusion from two true conditional statements when the conclusion of one statement is the hypothesis of the other statement. So it says, if P then Q and Q then R are true, then P then R is also true. Again, I like to stack it vertically instead of seeing it horizontally. So if P then Q, so that's an if then statement. There's our hypothesis is P, conclusion is Q. And then we have another if then statement that says if Q then R. And if you notice here, the last part of this sentence and the first part of this sentence are basically going to be saying the same thing. Okay. And so if our information is set up like this exactly, the conclusion that we can make is if P, then R. Okay. If the Q's are the same, then we should be able to stick a statement together with P and R, and it should be a true statement as well. So on example 4, use the law of syllogism to make conclusions based on the two true conditionals. What's given, if you can legally drive a car alone, P, then you have your driver's license, Q. If you have your driver's license, see how that is restating the last part of this sentence over here. So these are basically saying the same thing. It says, then you are at least 16. That's some new information that was brought into the problem. We haven't seen that yet, so we're going to give it a new letter R. Okay, and so our conclusion then is going to be if P, then R. We basically want to write that information and that information into a statement, and that will be a valid conclusion as well. So if you can legally drive a car alone, then you are at least 16. Okay, and then on example 5, it says use the law syllogism to make a conclusion. If, I guess I should say, if not possible, write no conclusion. So it says to take calculus P, you must first take algebra 2 Q. To take algebra 2, that's restating Q, you must first take algebra 1. That's some new information in our problem. So therefore, our conclusion that we can make is going to be if P, then R. We're going to say to take calculus, you must first take algebra 1. Okay, so hopefully you're starting to see the pattern a little bit here, that it's really just kind of like a formula that we're trying to follow. All right, on B, it says, if a tree has ragged bark, P, then the tree is unhealthy, Q. If a tree has ragged bark, can you see that that's restating P, not Q this time? Then the tree might be a birch tree. So that's some new information, and we'll call that R. But if I look at my little formula over here, again, I would try to remember this formula to stick at the top of my quiz or my test to help me see if it's in the right order. And if I look at this, okay, I really need the last part of this sentence and the first part of this sentence saying the same thing. And that's not how it is set up here. I've got the first part of each sentence saying the same thing. So I can't just stick the other two together and make a valid conclusion. So I'm just going to write no conclusion. If I tried to make a conclusion out of that information, it's just not going to make sense. If the tree is unhealthy, then the tree might be a birch tree. Um, Not necessarily. That doesn't make sense for it to definitely be a birch tree. Okay, then on example 6, it says use the law of syllogism or detachment to make a conclusion. If not possible, write no conclusion. So on this one, it says if a figure is a square, it's our P, then it's a polygon, Q. And it says figure A is a polygon. Again, think about if that's restating P or Q. And in this case, it's restating Q. So again, it's trying to make me think that it's detachment. But law of detachment should be set up like this at the beginning. And that is not what I see here on example 6A. So no conclusion. If I tried to make a conclusion out of that, it's not going to make sense. If I say just because figure A is a polygon, if I conclude figure A is a square, that's not going to make sense. All right, on B, last one here, it says if a student gets an A on a final exam, P, then the student will pass the course, Q. Felicia got an A on her history final exam. So again, that's basically restating P with this specific example of Felicia. So again, this one is set up like law of detachment, like I just showed over here. So I can reach that valid conclusion of Q. And I do want to use the specific example of Felicia. So I can say Felicia. And then I can just restate Q will pass the course. All right, so you are going to do the quiz 2-1 to 2-4 review now. Look back at your notes from section 2-1 to 2-4 if you need to do that for some help. I will post the solutions to that on Canvas for you to kind of check as you go. And then you will have a quiz similar to that review sheet in class on Wednesday or Thursday, whichever day you're there. It'll just be a 15, 20-minute quiz, maybe not even take you that long since there's no work on things, but it will be very similar to the review sheet. So just make sure you're understanding the different directions of what that is asking you to do.